What's up, people? Welcome back to the dirt bike shed. We're about to do some chemistry here. We're going to continue with yesterday's lesson on predicting chemical reactions, but yesterday's lesson was a little bit of a letdown because I didn't make a nice precipitate for you. So we're going to do one today that makes a precipitate. We're going to predict it. I'm going to show you how it works. I'm going to go a little bit quicker, okay? Forming precipitates in aqueous solutions, okay? That means we're going to make something visible in the water, all right? Let me get rolling. Let's go a little bit quicker here. All right, today we're going to mix some sodium hydroxide and some magnesium sulfate, all right? Now, this sodium hydroxide is aqueous. What does that mean? It means I had a beaker, and I put some water in it, make the water blue, and then I took some sodium hydroxide compound, solid powder, and I put it in the water. Now, when we got into the water, I'm zooming in on the water here, when we got into the water, the sodium hydroxide that's held together ionically, right? This crosses the stairs. It's held together ionically. Well, it's pulled apart into sodium positive cations and hydroxide negative polyatomic ions. The water pulls it apart, and we talked about this in class. The negative water end of the negative oxygen end of the water molecule pulls on the sodium, and the positive hydrogen end of the water molecule pulls on the negative hydroxide, so it's torn apart. When we tear the sodium hydroxide crystal apart, boop, it's invisible. So that's what aqueous means. And we just put a little AQ, which means this is dissolved in the water. All right, so aqueous sodium hydroxide, I've already got some of that. And now you and I together are going to make some aqueous magnesium sulfate. Let's move over here to the big bench, okay? Okay, now we've got a nice overhead shot of the mixer, right? There's the mixer. It's got a magnet that's spinning on it. It also has a heater, but I don't have the heater turned on. Now, I'm going to take my mixer. I'm going to put a little magnesium sulfate in there, okay? Just a little bit. Guess I shouldn't have the mixer on with just the powder in there, right? Now I'm going to add some water, just a little bit of water. Later we will measure how much water and powder we use, and we'll be able to measure the concentration or the strength of the solution, but today I'm just making a solution. So we're going to watch this stuff mix here for a second. Okay? Now, we had this powder, right? It's magnesium sulfate. It's really Epsom salt, people. That's what magnesium sulfate is. And then I put it in the water. So now we have an aqueous solution, right? So we made it. Okay, so what's going to happen when we mix these two together? All right, well, let's see here. It's going to be a double replacement reaction. So sodium is going to now partner up with sulfate. So that's going to be Na2SO4. Remember, we have to write our formulas correctly. Sodium is +1, so it has to be Na2SO4. And then now magnesium, it's going to hook up with the hydroxide. So we're going to have MgOH2. And what I'm going to do is balance this real quickly. Let's balance it together. So we got a 2 there. I'll probably put a 2 right there. It gives me 2 sodiums, 2 hydroxides, 2 hydroxides right there. And we're done. 2, 1, 1, 1. It's balanced. Now, let's look at this and let's figure out, and I'm promising you this is going to be a cool reaction. We're going to make a precipitate. Let's figure out which one of these bad boys is going to be the precipitate that we see in the water. All right, looking right here on our solubility rules on page 6. The first one we have a choice to look at is sodium sulfate, okay? Sodium sulfate, all right, right here. All sulfates are soluble except calcium, strontium, barium, mercury, lead. So that means sodium sulfate is soluble. So sodium sulfate is going to be aqueous. It's going to be soluble. We are not going to see that in the water. Magnesium hydroxide. Let's check on it. Let's check on magnesium hydroxide. All right. Whoops, went the wrong way. Hydroxides. All hydroxides. All hydroxides right here. All hydroxides except strontium, barium, and ammonium are insoluble. Therefore, magnesium hydroxide is going to be insoluble, right? So what are we going to see in the water? We are going to see magnesium hydroxide. It's going to be a precipitate. We put PPT here. So we can predict that this is what we're going to see in the water. All right, we're back over here at the bench. We're going to actually do this reaction that we balanced and then predicted. It's a double replacement reaction. Here's some sodium hydroxide. It's a clear liquid. It's already been mixed. Okay. Boom, I got it right there. Got myself some sodium hydroxide. You can see it's aqueous. It's clearly aqueous. Let me stand this bad boy up right here. We're in the dirt bike shed, so why don't we just put it in a little socket? Isn't that cool? And now magically, I've got an empty test tube here waiting. Right, in my socket here I have sodium hydroxide. And now we just made this magnesium sulfate. I'm going to put it in another test tube that's fairly clean. Remember, in the dirt bike shed, we're not super clean here. We're just doing our best. Boom. All right, I got some magnesium sulfate right here. So this is aqueous magnesium sulfate. This is our sodium hydroxide, NaOH plus NgSO4. We're going to do a double replacement reaction. Boom. Here we go, pouring in the sodium hydroxide. All right. And then here comes the magnesium sulfate. Ready? Oops, I got to hold the camera still. And boom. Now that was pretty cool, right? What is that white gel we see in there? What is the precipitate? The precipitate that we're seeing here, the precipitate, this white precipitate is magnesium hydroxide. So let's go over here. Let's go over here. And I can tell you that this white gel that we just made in our test tube is magnesium hydroxide. Now, I'm going to post an assignment with this, and I'm going to give you equations, and all I want you to do is circle which one of the products you believe will be the precipitate. I'll tell you what, I'm going to have you balance the equation and then circle the precipitate. Sound good? That's it from the dirt bike shed today.